Okay, بسم الله الرحمن الرحيم. Finish now the exams. Now we'll go to the old exams questions. I think this is starting from term 161 until the last term, 231. So let me do it, which is related to this section, 9.2. So this series, if you think about it, n equal 1 to infinity, e to the power n plus 1 over e to the power 2n plus 1 minus e to the power n over e to the power 2n plus 1. Yeah, let me do calculation. I have e to the power n plus n e to the power minus n. Okay. Minus e to the power of what? This one. It will be, take this to the, it will be e to the power minus n minus 1. Okay. So now this is how I will do it. Yeah, this one geometric, is it? Or telescopic? Yeah, you can deal with it as a geometric one, and you can think of it as, you can do it actually in two ways. You can do it as this one, 1 over e or n, this is very clear geometric, minus summation n equal 1 to infinity. This is what? 1 over e to the power n times 1 over e. And then you deal with it as a geometric one. Let me do it as a geometric. That will be what? Yeah, this one, if you want to write it in the format, I have summation equal 1 to infinity. We can do it a right away, huh? A is 1 over e, huh? A is the starting point, and the r is 1 over e. So in this one, I have 1 over e over 1 minus 1 over e. Okay, minus. This one you have what? What is my starting point? It's a equal 1 over e square, but r equal 1 over e, which is converge, huh? Yeah, converge, are satisfying the condition. So I have 1 over e square over 1 minus 1 over e. So that'll give me what? That'll give me 1 over e. This is e over e minus 1 minus, let me put a bracket, 1 over e square. This one will be what? E minus 1 over e. I make the reciprocal. Okay. So that'll give me what? Here, this is the square. So the result is 1 over e minus 1 minus 1 over e minus 1. So common factor, e minus 1. Divide by this, I have e minus 1. So this is cancelled. So I'm getting 1 over e, which is this one. I think also you can think of it as telescopic. Yeah, because it will be eos minus 1, huh? Minus eos minus 2 plus eos minus 2 minus eos minus 3, and so on, until you reach this. Another way, huh? So this cancelled. So as s goes to infinity, this goes to 0. As n goes to infinity, that goes to 0. So I have 1 over e. Another way to think about it. So you can do it telescopic, you can do it geometric. Geometric, you need to do two cases. Okay. This one, this series. If we look at this series, what is an? An will be ln to n to the power 4 plus 1 minus ln n to the power 4 plus 1. Okay, which is ln to n to the power 4 plus 1 over n to the power 4 plus 1. So it will be the limit of an as n goes to infinity. It will be the limit as n goes to infinity of this ln, yeah, to n to the power 4 plus 1 over n to the power 4 plus 1. Can take, since ln is a continuous function, I can take the limit inside. I'm doing it in details. Huh? If you want to solve it, no need to do all of this. That will be ln. This is what is this limit is 2. So the limit of an is not equal to 0. So this series diverges by the test for divergence. Okay. This one is what? Yeah, for sure it's not geometric. Can't think of it as telescoping. Let me check. So it will be Sn or Sk. It will be A1 plus A2 plus A3 plus AK. That will be what? Cosine. I'm starting from 2 actually. Okay. A2. Yeah. A3 plus A4 plus AK. Yeah. Since n equal to. That give me what? That's Sk or Sk minus 1 or what do you call it? No. Sk. You call it Sk or S. Yeah. Until I reach K. That give me what? Cosine of what? 2 pi over 2 minus cosine 2 pi over 3 plus cosine 2 pi over 3. No need to find it. Minus cosine 2 pi over 4 plus cosine 2 pi over 4 minus cosine 2 pi over 5 plus, yeah, cosine 2 pi over n minus cosine 2 pi over n plus 1. Yeah. K. I'm talking about K. K or n. Do I like it? For sure, these are cancelled. And this one also cancelled. This one also cancelled. So I have what? Cosine by cosine by minus cosine 2 pi over k plus 1. So what will be S will be the limit as n goes to infinity of S as k goes to infinity of sk. Cosine pi is minus 1. So that will be minus 1 minus, as k goes to infinity, that will go 2 pi over infinity, which is 0, minus cosine 0, which is minus 1 minus 1, that will be minus 2. And that will be the answer. So it's converge and its sum is minus 2. This one, very clear, this is a geometric. So this one, I can rewrite it in when 1 equal n to infinity. Yeah, be careful. 5 to the power n times 5 over 9 to the power n. So that will be summation n equal 1 to infinity. 5 over 9 to the power n. To make it in the format, I take 5 over 9 outside times 5 over 9 to the power n minus 1. So now this is A and this is R, less than 1 as an absolute value. R converges since absolute value of R less than 1. And what is the sum? It will be A 5 times 5 over 9 over 1 minus R. That give me what? 25 over 9 times. This is 9 minus 5, 4 over 9 times its reciprocal, cancelled, 25 over 4. That's it. Yeah, this one is what? N equals 0 to infinity. I have 3 minus 2 over 8 to the power n. So it will be summation n equals 0 to infinity, 3 minus 1 over 4 to the power Okay. So what will be A? A will be at n equals 0. It will be 3. And R minus 1 over 4. Note absolute value of R less than 1. So it converges. And what is the sum? It will be A over 1 minus R minus 1 over 4. That will be 3, 5 over 4. That will be what? That will be 12 over 5, which is 2 plus 2 over 5, which is 2 plus 0.4, which is 2.4. Which is this one. 2 over n squared minus 1. I can rewrite it. N equal to infinity. 2, not 2. Yeah, this is n minus 1 times n plus 1. So it will be A. I can take the 2 outside. Let me do it in steps. 1 over n minus 1, n plus 1. That will be 2 summation of 2 to infinity. This is A over n minus 1, B over n plus 1. That's how we deal with this one. 2 just multiply at the end. So now cover n minus 1, substitute 1, A equal half. Cover n plus 1, and substitute minus 1. I'm getting minus half. So it's 2 summation n equal 2 to infinity. Half over n minus 1 minus half over n plus 1. You know what? I can take the half outside also. So it will be 1. So that will be summation n equal 2 to infinity. 1 over n minus 1 minus 1 over n plus 1. Okay. Now let me open it. I have what? And 2, I have 1 over 1. Minus 1 over 3. Okay. Plus. Now with n equal 3, I have half. It's not cancelled. Leave it, okay? Let me see what will happen. At n equal 3, I have minus 1 over 4 plus at n equal 4, that will be 1 over 3 minus 1 over 5 plus at n equal 5, that will be what? At n equal 5, that will be 1 over 4 minus 1 over 6. I notice they will cancel after 2 steps. So when I do, no, 5. By the way, this is SK, huh? Or SN, let me say. But I want the sum up to n, which is summation n equal to, which is S2 until Sn, huh? Yeah, until AN, I mean. This is A2 plus AN. So this is A2, this is A3, this is A4. I notice in every 2, they will be cancelled. So I will do AN and AN minus 1 and AN minus 2, just to be sure. So this is plus. When I have n minus 2, I have what? 1 over n minus 3 minus 1 over n minus 1 plus when n minus 1, that will be 1 over n minus 2 minus 1 over n plus when n, the n I have 1 over n minus 1, can make it n plus 1, who cares? Okay. Plus minus 1 over n plus 1. If you notice, this is cancelled. Yeah. And this one cancelled also. and this one will cancel somewhere, and this one will cancel somewhere. So the remaining will be what? 1 plus half. This will remain, this will remain. And also in that one, this for sure it will be cancelled somewhere. And this one also cancelled somewhere. Before this, I have n minus 2 somewhere here. So this is cancelled. Minus 1 over n minus 1 over n plus 1. So what will be s? Will be the limit as n goes to infinity, as k goes to infinity of sk, which is 1 plus half minus 0 minus 0. So it will be 3 over 2. The new things, I have 2 remains, not only 1. The cancellation after 2 steps, not after 1 step. Yeah. This one we need to rewrite it first. Be careful. That's summation n equal to infinity. 2 times 2 to the power n times what? 9 to the power half times 9 to the power minus n over 2. Is it? Yeah, this is half minus n over 2. Okay. So now let me do the calculation. N equal to infinity. That will be 2 times 2 to the power n times 3. This is 3. And this is 3 to the power minus n. So it's actually 6 summation n equal to infinity. 6 times 2 over 3 all to the power n. So do the first. What will be A? The first step, it will be 6, 2 over 3 square, which is 6 times 4 over 9, 3, 2, which is 8 over 3. What is R? R is 2 over 3, converges. R is the absolute value of R less than 1. So it will be this summation. It will be A, 8 over 3 over 1 minus 2 over 3. So it's 8 over 3 over 1 over 3, which is 8. That will be the answer. 1 over 3 to the power 1 over n cubed. This is geometric. No, it's not geometric. If you take an as 1 over 3 to the power 1 over n cubed, what is the limit of an as n goes to infinity? It will be 1 over 3, 1 over infinity, 0. And the answer is 1, not equal to 0. So the series converges. Diverges, sorry. This for divergence. Let me do this one. What will be this? It's 1, 4 over 10, plus 16 over 10 square, plus 64 over 1000, 10 cubed, plus. So it's 1 plus. This is 4 over 10. This is 4 over 10 square. This is 4 over 10 cubed. Now, very clear, this is geometric. What is A? A equal 1 and R equal 4 over 10. Because the ratio will be 4 over 10. Note absolute value of R less than 1. So what will be the sum? It will be A over 1 minus 4 over 10. And this will be 1 over 10 minus 4, 6 over 10. So it's 10 over 6, 5 over 3. Okay. Consider the series. This is the sequence of partial sum. He gave me Sn. The sequence of partial sum is this. Find the limit of an. What will be the limit of an as n goes to infinity? I don't know. However, what I can figure out that this series, since the limit of Sn as n goes to infinity will be 1, so this series converges. And actually, its sum is equal to 1. But that is not the limit of an. How to find the limit of an? as n goes to infinity. That will be what? Notice, yeah, in the n term for divergence, before that, we have this theorem. What is it? Yeah. If the series is converge, what will be the limit of an as n goes to infinity? It will be 0. Since I know the series converges, since I know the series converge, I know the series converge, the limit of an should be 0. Since I get from there this sequence of partial sums, so the limit exists, so the series converge. So the limit of the n term should be 0. 7 times minus 1 to the power n minus 0.75 to the power n. Yeah, let me rewrite it. That will be 7 minus 0.75. What is 0.75? 3 over 4 to the power n. That's the problem. So first one, A will be 7. And what is R? Minus 3 over 4. Notice this is less than 1, converge. So what will be the sum? A 7 over 1 minus R, minus 3 over 4. That will be 7 over 4 plus 3, 7 over 4. That will be 7 times 4 over 7, and that is 4. That will be the answer. Integral. Integral of k to the power k plus 1 over 1 plus x squared. You want the sum of this. Okay. How to do this? Notice one thing. This is 0 to 1 plus 1 to 2 plus 2 to 3 plus 3 to 4 plus k to k plus 1 until I reach infinity. This of this expression. Yeah, if I write it correctly. 1 to 2, 2 to 0 to 1, 1 to 2, 2 to 3. And that is what? I know A to B, B to C, that means A to C. So that will be integral from 0 to infinity of this. Yeah, it's clear. Yeah. So what I have, how to do this? Yeah, I can do it using the limit. So I have the limit as t goes to infinity, 0 to t, 1 over 1 plus x squared dx. And that will be the limit, t goes to infinity of what? Of tan inverse of x from 0 to t. Yeah. And that will be the limit as t goes to infinity of tan inverse of t, tan inverse of 0, 0, خلاص. What is the limit of this? Tan inverse of infinity. That will be pi over 2. And that will be my answer. This geometric series is what? Yeah, it's very, he said geometric series. So what is A? First term at 0, pi minus 4 to the power 0, which is 1. And R is pi minus 4. Absolute value of R less than 1? Yes. Pi minus 4 will be something less than 1 with a negative value. This is negative, is less than 1. So converges. What will be the sum? A over 1 minus R. And that will be 1 over minus 4, 5 minus pi. That will be the answer.